Hello students, welcome back to the lecture series of software engineering course. Today I will cover one of the most interesting topic in software engineering, that is ER diagram, entity relationship diagram, that comes under the information models. And as you have all heard, ER diagram in database management system for modeling the data so that it can be easily converted into the tables or relations and our database would get completed or would get designed easily. But in software engineering, especially in the requirement engineering, for modeling the information to make it more understandable, we are using this ER diagram. So here, the definition of ER diagram mentioned over here, ER model is an information model used in software engineering to produce conceptual model of an information system, or generally information system are the software systems. And the components, basic components used in ER diagram are three. One, entities. Entities are basically any real world objects that can be easily identifiable and has existence are called entities. In fact, if I said I'm an entity, you are an entity. So an entity can be anything. So I am an entity. I can be a single entity. So there are two important things in this entity. One is entity and another one is entity set. So any entity which is actually sharing the same behavior or same properties, then it comes under the entity set. So if I am the faculty, so I comes in the faculty entity set. You are the student, so you comes under the student entity set, right? So, but in major cases, entity set and entities can be used interchangeably. So if I name entity, that means most of the time I said entity set. So I hope you understand. The second are the attributes. Attributes are actually the properties of the entity sets. So any characteristics of the entity set which identify that entity is basically called the attributes. So there are four types of attributes. One is the key attribute. Key attribute which uniquely identify the whole entity set is actually called the key attribute. For example, the student's roll number, which actually usually identified the student. So if I put roll number anywhere else, I can fetch all the data of the students. So roll number is uniquely identify the student. So that if any property which uniquely identify the whole entity set, that attribute is called the key attribute. The second one is composite attribute. Most of the properties are actually get completed when they are composed of small other properties. So composite attributes, for example, if I said name, so name can be first name, middle name and last name. For example, address. Address can be the room, the house number, the street address, the state, the country. So all these composed of those attributes. So we called it as composite attribute. Next is the derived attribute. If I can induce or derive one attribute from the another, then such attribute are called the derived attribute. For example, from any date of birth, I can easily derive the age of the particular person, or from any marks of the student, I can easily derive the percentage of the student. So percentage or age, such kind of attributes are derived attributes. Multi-valued attributes, the attribute which has many values. For example, any student can have multiple mobile numbers. Any student can have multiple hobbies. So such kind of attributes are multi-valued attributes, which has many values. So attributes, hope you understand, are the properties of entities. The third one are the relationships. Relationships, basically the relation between among the entities, or the connection among the entities. So here I am using relation, but whenever I talk about in database management system, then we cannot say relation among the entities, because their relation means over the tables. So here I am talking about the connections among the entities. What are the connections among the entities? What are the relation among the entities? So basically they are called the relationships. So relationships can be unary, can be binary, can be ternary. Relationship can be with this, any entity can have the relationship with this, with the own entity. Any relationship can have with their another entity. Any relationship can have the more than two entities. So on that basis we can identify the relationships. But here I identified on the basis of cardinality ratio. So there are four types of ratios, cardinality ratios in any relationship. First is 1:1, 1:n, n:1, n:m. 1:1, generally these ratios defines the ratio of the entity who participates in any relationship. For example, if I talk about the 1:1, so if for example, I can teach only one subject, and that subject can be taught by only one faculty. So that means there is 1:1 relationship, right? Second is 1:n. For example, I am teaching to multiple students, and students can be only teach by me. I can only teach them. So this relationship is 1:n. The same happens if I talk about the inverse of it, then it is n:1. n:m. Students can be taught by many faculties, and faculties can teach many students. So relationship can be n:m. So these are the ratios. There are much more about these components and their types, the constraints applied on those constraints. So we won't go to that extent or to that deep. The objective of today's class, you could be able to draw a simple ER diagram. So there are much more if I talk about ER diagram, there are much more to teach, there are much more to learn, but we are not going on that deeper sense. We are only getting the general sense, or we are going to only tell you how to draw a simple ER diagram. So what are the notations we are used in ER diagram? Generally, ER diagram is a standard diagrammatic representation of an information, right? So if I talk about the standard, so there should be some standard notations, so that everyone can be able to understand. If I draw particular symbol or something else, then it can be easily understandable by everybody else, universal. So that's why there are some standard notations to draw an ER diagram. So for any entity, we do use the rectangle, right? As simple as that. For any attribute, we are using simple the oval shape symbol. For relationship, we are using the rhombus, or you can say the diamond shaped symbol. For any key attribute, because it is an attribute, so obviously it will be in oval shape, but for key attribute, there would be a line inside the oval shape. Composite attribute, as it is composed of many attributes, so it can be this one, right? And derived attribute, that is in the dotted lines. Again, multi-valued attribute, so it can be in the same, but there could be the attributes, right? So this is all about the notations used in the ER diagram. Now it is very important how to draw an ER diagram. So there should be some certain steps to draw an ER diagram. So the steps I have already written over here. The first step, we need to define the purpose and scope what you are analyzing and modeling. So initially, whenever I start an ER diagram, so initially I should know the scope of that ER diagram, because if I decide to I decide some application and draw an ER diagram, so we need to decide its boundaries, its scope, at what extent I need to go. Because whenever we pick some application, then there is no extent, or there is no, because whenever we talk about the quality doesn't have any limit. We can go beyond any limit, or we can reach to any deeper point, right? So firstly, whenever we need to start an ER diagram, we need to define the scope and purpose of an ER diagram. The second is we need to define or identify the entities, and that entities can be named in noun terms. The third step is we need to determine how entities are related. I mean, this means that we need to identify the relationships among the entities. So how entities are related to other entities, we need to identify those relationships. In the step 4, we need to mention the attributes of the entities. We need to mention the properties of the entities. Including that, we need to add more details. We need to define the key attributes of the entity. So already told you there are 4 types of attributes, key, composite, derived attribute. So it would be good if I will be very specific related to the properties of entities. The step 5, I need to find out the relationship ratio, constraints, cardinality ratio. What is the ratio of participation of entity for any relationship? So step 5 mein we need to find out the cardinality ratio. And step 6, simply I need to draw an ER diagram. Now, as an example, today I will give you a very simple example of college database. So, college database, because college is if I take the college application, then the whole is very wide. I'm not talking about multiple colleges, I'm talking about a single college, right? Because if I talk about the multiple colleges, that would be a university database. So I'm taking simple example of college database. So what exactly I did, I start with the first step. I start with the purpose and scope, or analyze the whole application and model that in simple English words. So what exactly in the college database, I define the college database scope and purpose as the college contains many departments. Each department can offer any number of courses. Many instructors can work in a department. An instructor can work only in single department. For each department, there is a head. Any instructor can be head of only one department. Each instructor can take any number of courses. A course can be taken by only one instructor. A student can enroll in any number of courses, and each courses can have any number of students. So this is actually my college software system, where I firstly define how exactly I define or introduce the college database, and what is the scope or what is the purpose of the college database. So I need to consider small things, or I need to visualize small things, and on that basis I simply write it down in simple English like words, right? So this is actually the problem which I need to draw an ER diagram. So I will follow these steps, obviously the notations, obviously the types also. So let's start how exactly we will draw an ER diagram. So as I told you, in the first step has already been completed when I actually stated the whole problem. The second is I need to identify the entities, right? So obviously I'll start with the nouns which are included in the statements. Obviously I won't take college because it is not university database already, it is a college database. So I won't take college. I will just underline those which are entity in this given statement. So as I can see the department, as I can see the courses, as I can see the instructors, and as I can see the students. So if I check out this whole problem statement, then automatically in the second step 2, this was the step 1, in the step 2, the entities are so if I check out this whole statement, then obviously in the step 2, we are identifying the entities. And what I did, I just put all the entities, so I can find there are 4 entities into it, right? In the step 3, I need to find out the relationship among these entities. So in the step 3, I need to find out the relationship. So if I talk about the department and the courses, so obviously there is one relation, that is department offers courses. As simple as that. So this offers is one of the relationship between these two entities, right? Department has instructors. So again, this is one of the relationship between department and instructor. Instructor, courses are taught by instructor. Courses taught by instructor. So as you can see, those courses can be taught by instructors. So taught by is the relationship between these two. Courses enrolled by students. In fact, I can say instructors teaches to students. So this can also be the relationship. Obviously, I can say department headed by the instructor, because I mentioned over there. So I will write over there department headed by instructor, which would be the head. So whatever the statement I have defined the scope or the boundary of the problem statement, I need to retrieve the relationship from those given statements. Or if only it has been given, you need to draw an ER diagram of college software system or university software system, then you can only visualize at what extent you need to go and what are the constraints you need to apply and how many relationships you need to put among the relationship among the entities. That is up to each individual. The goal is to make the ER diagram correctly, right? So this was the step 3. Now it is mentioned over there, step 4, we need to identify the attributes. So rest of the attributes we will draw at the time of when we will draw ER diagram, but I need to identify the key attributes. So in the step 4, I will identify the key attributes. So first entity was department. So any college has one department only, because if I say about computer science, then only one computer science department in any college. There is no two same departments existing in a single college. So obviously for department entity, we will decide department name as the key attribute. So this is the key attribute of department, right? The second is courses. For this, course ID is the key attribute of courses. Instructor, we will pick instructor ID as same names of 2 instructors can be possible. So we will identify by some instructor ID or employee ID. Or student, obviously same name of 2 students or multiple students can we have, so we do pick student ID as my key attribute. So I have decided these, firstly the entities, secondly the relationships, thirdly I have made the key attributes, and rest of the attributes I will mention at the time of drawing an ER diagram. The rest I talk about the cardinality ratio, that I need to show the participation ratio of each entity. So if I talk about department offers courses, so here each department can offer any number of courses. It has been mentioned over there, but many instructors can have there. So what exactly we will do, each department can have any number of courses, means department can offer multiple courses, but single course can be offered only by the single department. So I put over here 1:n relationship, right? Same happens, department has instructor. So here mentioned many instructors can work in the department. Any department can have multiple instructors, but instructors can only dedicated to single department. So here again we talk about the department has many instructors, 1:n. Now courses taught by the instructors. So here mentioned a course, each instructor can take any number of courses. A course can be taken by only one instructor. The each जो courses है can be taken by any instructor, but instructor can take only one course. So this is n:1, right? Courses enrolled by the student. So last line, as you can see, a student can enroll in any number of courses, and each course can have multiple students. So here n:n. The next, each department there is an head, and an instructor can be head of only one department. The department headed by the instructor, the relationship is 1:1. So finally, we have identified all the cardinality ratio between the relationship between entities. So now the last step is I need to draw an ER diagram. So let's draw it, an ER diagram. So obviously, as you can see, department is an entity. So we mention it as in a rectangle box. Then I already told you department offers courses. So there should be a relationship offers, as courses are basically the entity. So department offers courses. Obviously, second is that department has instructors. Right? Courses are taught by the instructors. Courses enrolled by students. And department headed by instructors. So I have drawn a structure, a partial structure. Now I need to add the attributes. So department has one attribute as department name. So I would write D name, and it could have department location, means in some location department exists, which actually identify the department property. Now courses has course ID. So obviously ID is the key attribute. So I will underline it. Courses has course name. Courses have their credits. So I will mention there are only 3 attributes for the courses. Now instructor has instructor ID. Instructor has name. Instructor has mobile number. Instructor has its gender. So these are the attributes instructor. Now come to the student. Student has their student ID as an key attribute. Student has their name. Student has their age. Student has some address, mobile number that could have. So by this ER diagram, you can easily see I have already drawn the entities, the relationships and the attributes. Now it's time to put the cardinality ratio. So department offers multiple courses, 1:n. Department has instructors, 1:n. Department headed by instructor, 1:1. Courses enrolled by students, n:m. Courses taught by instructor, n:1. So in this way, I have drawn a simple ER diagram of this given example, of college database, where I already designed a scope or the purpose of that college software system. There are many more in ER diagram, as you have heard already in the database management system course. That is an extended ER diagram, because ER diagram is not that enough to depict or to represent the databases or to data model. So my objective in today's class is to tell you how to draw a simple ER diagram, how to write the problem statement, or to define its constraints, to define its boundary, to define its scope. So I'm expecting you understand today's lecture. If you do have any kind of doubt, you may ask to me, or you may write in the comment box. So thank you, students. Keep watching and listening.